Assalamualaikum and good morning. Today we want to present about the assignment given to us is for subject Advanced Electrical Circuits. Our titles given is about transfer functions, and our lecturer is technologist Dr. Suraya binti Zainuddin. We begin with group members. First we have Nafis bin Muhammad Tarmi. Their matrix number, his matrix number is B1224-10668. Second, we have Muhammad Aminul bin Matsani. His matrix number is B1224-10663. Third, we have Adam Harishilan bin Ahmad. Is B1224-10657. And lastly, in my group is me is Muhammad Hanafi bin Anwar, and my matrix number is B1224-10120. We begin with introduction. Our titles given is about the transfer function. Okay, what is transfer function? Transfer functions in mathematical model that describes how circuit respond to different input signal. Okay, this is the transfer functions. Transfer function is defined as the ratio of the Laplace transform of the output to the input, assuming zero in initial conditions. What is the importance of the transfer functions? The transfer functions is to simplify the analysis of the dynamic system, such as filters, amplifiers, control systems. Other than that, transfer functions help to predict stability, frequency response, and tension behavior. Lastly, the importance of the transfer function is foundation for circuit design, signal processing, and feedback control.
Hello, my name is Nafis bin Muhammad Tarmi. Matric number B1224106668. So right now, I am going to show how to change this transfer function into general form for the board plot use. So this board plot will be included with the general form of the board plot and the phase of the board plot. So the given question is that we need to factorize this from the numerator and denominator. So you will get that 2 will be outside and also 10. So to prove that we will get this original function back, you can always expand it back into this function. You will get 2 will be equal by 2, you will get j omega, and 2 will be times by 1, you will get 2. So we will get the same function as before. Same goes at the denominator. Same goes for denominator. So for the next step is that you can simplify by proceed with the 5 times 2, you will get 10, and you also have 10 at the denominator, so you can always simplify it. You will get 1. Now, so the last step is that you will get your general function that can be used for the board plot and for the phase board plot. So this you can arrange it back by 1 plus j omega divided by 2 over j omega times with 1 plus j omega over 10. So this will be your general function for the board plot. So at the numerator, this will be your simple 0. At denominator, this will be your simple pole, and this will be your pole of origin. your pole of origin will be 1 over j omega, because as you factorize it out of this function, you will get 1 over j omega. So now we will start with our bird plot. So the step for the bird plot is that you need to simplify one by one. So first, we will start with the simple zero. So from the simple zero function, you will get that 0 will be equals to 2, and it will increase 20 decibels per decade. So for the line of the simple zero, it means that the line will be start from here until 2 and will rise until 20 for a decade. For a decade means that after 2 will be times by 10, you will get 20. This means 1 decade. So it will rise until 20 at 20 frequency. It will rise until 20 decibel at 20 frequency. So it will continue rise until its second decade will be 200. By then it will be reached by 40 decibels. So we are done with the simple zero. Now let's refer to the proper graph. The proper graph is the simple pole. From this function, our poles will be 10. So this means that the line will reach until third frequency of 10, so it will decrease into negative 20 decibels. So right now, it's the same as before. The line for the simple zero, simple pole, will start from here and it will reach until 10. And from 10, it will go into negative 20 for a decade. For a decade means from 10 will be times by 10, you will get 100. So it will reach negative 20 decibels by 100 right here. So it will continue to reach negative 40 decibels by 1000 after 1 decade. Now we are done with the simple pole. And the last one is the pole of origin. The pole of origin states that the line must pass frequency of 1 to reach negative 20 decibels. So this means that you need to focus on the green line. So it will starts from the 0.1 at 20 decibels right here and pass at 1 frequency of 1, and reach into negative 20 decibels by a decade. Each one is by a decade. So it will continue decreasing until 100. Also means by a decade, as you can see. At the frequency of 10, it already reached negative 20, and at the frequency of 100, it already reached negative 40 decibels. So now we are done with both three functions. So the last step for the bird plot is to find its magnitude. So the magnitude of the bird plot is the change of graph at the range of the frequencies. So as you can see, from 0.1 until 1, you have 3 types of line. So ignoring the yellow line is the magnitude. So you will have 2 lines at the middle and 1 line at here. This will be your poles of origin. And here we have simple zero and simple pole. So since there is no slopes, Since there is no slope, thus it will carry the value of 0, while the poles of origin carries the slopes of negative 20 decibels. That's why the magnitude only focus on the change, which is the poles of origin. That's why you only have one line. That's why you only have the magnitude of the bird plot following the pole of origin for the range of 0.1 until 1 frequency. Now we will look for the next range, and that is the 1 until 10 frequency. As you can see, the pole of origin has went down right here until negative 20 decibels, and the simple 0 has positive 20 decibels, and the simple pole has 0. Thus, to find the magnitude at this range, you can do some mathematical calculations, which is 20 decibels minus 0 and then minus with negative 20 decibels. You will get 0. Since it's 0, the magnitude of the bird plot will be flat right here. Now we will repeat the same step for the last branch of the frequency, which is 10 until 100. So at this range, we also have the range of 20 decibels. This is because if we look at this range, we only have the range of 40 decibels until 20, which means we only raise about 20 decibels, not 40. So we have 20 decibels, and up against with the simple pole of negative 20 decibels and the pole of origin of negative 20 decibels. So if we do our calculations, you will get negative 20 decibels, as this cancel each other, and the last result is the negative 20 decibel. That's why the line of magnitude for the bird plot at the last few frequencies will go down right here. It will decrease until negative 20 decibels. So now our bird plot for the first question has completed. Now we will look into the phase of the bird plot. For the phase of the bird plot, the step is still the same as before, which is the simple. We have the simple 0, simple 0, simple pole, and your pole of origin. From the simple 0, your your 0 will be equals to 2, and then it will need to be divided by 10. You will get 0.2, and also times by 10, you will get 20. Same goes for the simple pole. Simple pole is equals to 10, divided by 10, you will get 1, and times 10, you will get 100. So this calculation is our key point to know at which frequency that the graph will be changed. So let's focus for the simple 0 first. For the purple line, this is the simple 0. For the simple 0, it will change at 0.2. This will be a 0.2. This is because from our calculation before, when 0 equals to 2 and divided by 10, you will get 0.2. This will be the point where the graph will change, and this will be the point where the graph will be 90 degrees. For the simple 0, it will start to change from 0.2 and rise until the frequency is 20. From this point, the graph will have 90 degree. So your slope, so right now you have a total of 2 decades from here to here. For 2 decades you will reach 90 degree. So for 1 decade you will reach 45 degree. So this states that the angle of the slope is 45 degree. Now you proceed with the simple pole. For the simple pole, which is the red line, simple pole will start to change at frequency of 1 and stops at frequency of 100. So as you can see, at frequency of 1, it starts to decrease until it reaches frequency of 100. So it is the same step as before, except that its 90 degree will be negative since it is located at the negative sides of 1. So you will get negative 90 degree. And the slopes will be the same. And that is negative 5 degree per decade. And the last part is the poles of origin, which is the yellow line. The poles of origin will be the simple line because it does not have any calculation since it is 1 over j omega, which indicates it is negative 90 degree. So you will have a straight line of negative 90 degree until the end. So the last part is that we need to find its magnitude, which is the purple line. So let's focus on the purple line. So it is the same step as before. We need to focus part by part at the frequency. So let's focus on from 0.1 frequency until 1. As you can see, for the simple 0 you have 45 degree, and the simple pole you have 90 degree, and the poles of origin is negative 90 degree. So the sum of the degree you will get from this range will be 45 degree, as 45 will plus with 90 but minus with negative 90, but minus with 90 you will get 45 degrees. So your magnitude line will be rising up. So moving on to the next range, and then minus with negative 20 decibels, you will get 0. Since it's 0, the magnitude of the both plot will be flat right here. It's the same as before. The line for the simple 0, simple pole, will start from here and it will reach until 10. And from 10, it will go into negative 20 for a decade. For a decade means from 10 will be times by 10, we will get 100. So it will reach negative 20 decibels by 100 right here. So it will continue to reach negative 40 decibels by 1000 after 1 decade. Now we are done with the simple pole. And the last one is the pole of origin. The pole of origin states that the line must pass frequency of 1 to reach negative 20 decibels. So this means that you need to focus on the green line. So it will start from the 0.1 at 20 decibels right here and pass at 1 frequency of 1, and reach into negative 20 decibels. So from this range you will have positive 90 degree, and you will have negative 45 degree and negative 90 degree. As a result, you will get the magnitude of negative 45 degree. And I think that's all from me. Thank you.
Hi, my name is Adam Harish. My number metric is B122410657. So right now I will discuss about the question G answer. Okay, so right now I already have labeled the line. There are first, second and third and fourth line. So the first one is a straight line, which is gain. So the gain formula is 20 log 10 K. So the K we got the value K from the y-axis, which is 20 at the starting of the line, and then the K will be divided by 20, and then the K value will be 10. We got it from the log 10 times with the K divided 20 divided by 20, and then times with the log 10, it will get 10. So the second line will be simple zero with the omega value is 10. The simple zero formula will be 1 plus j omega over z. So the z will be changed to the omega, which is 10. So the value is 1 plus j omega over 10. So that is the second line. So the third line will be simple pole. Why is it simple pole? Because the second line will be increasing, and then the third line is just a straight line. So to make a simple zero to a straight line, we will have to add a line that decreasing, which is simple pole. Okay. So the simple pole omega is 100. So the formula is 1 over 1 plus j omega divided by z. So the z will be changed to the omega, which is 100. So the value will be 1 over 1 plus j omega equals to 100. Okay, so the last and the fourth one is simple pole because the line is decreasing. The omega will be 1000. Okay, so the formula is it is the same as the third line, which is 1 over 1 plus j omega divided by z. Just change the z to 1000. So it will be 1 over 1 plus j omega divided by 1000. Okay, right now we have to find the h omega. Okay, so add all of the formula into one formula. So it will be 10 in bracket 1 plus j omega divided by 10 over in bracket 1 plus j omega divided by 100 and in bracket 1 plus j omega divided by 1000. So we have to simplify all of this, and lastly we got the value 100,000 times in bracket j omega plus 10 over in bracket j omega plus 100 in bracket j omega plus 1000. So we have to change the j omega to s function. So it will be 100,000 in bracket s plus 10 over s plus 100 and in bracket s plus 1000. So that's all for today. Thank you.
In the discussion part for transfer function, the mathematical relationship between a system input and output in the frequency domain is represented by the transfer function. It was used to determine how the circuit behaves across a range of frequencies. The transfer function helps in determining cut-off frequencies and predicting gain at different frequencies for both high-pass and low-pass filters. For the baud plots, the baud graphic shows the frequency-dependent change in phase shift and output gain with its magnitude. Phase angle against frequency and magnitude dB against frequency form is two-component. The plot allows one to determine which is the cut-off frequency at which a 3 dB decrease in gain happens, and the alternation rate after the cut-off point is usually negative 20 dB per decade for a first-order system. And for a conclusion, the findings of the baud plot and transfer function analysis make it clear that both are crucial for understanding the frequency response of a circuit. The baud figure show gains and phase differences across frequency while the transfer function offers the mathematical basis. The observed outcome verify the proper operation of low-pass and high-pass filters by matching theoretical predictions. For the analysis, design and verification of electronic filter circuits in the real-world application, and these techniques are essential. Thank you.